CDN and performance and cost economics, not very sexy, but needs to be understood. A little bit about who I am. I am Stephen Tripsas. I am the Platform Solutions Architect at Zype. I worked in finance IT for the majority of my life from 19 to 27. I worked for the Blackstone Group. I was Assistant Vice President of Tech Operations, Trading Platforms. I also work for Rockstar Games, building Red Dead 5, building Noir. I exclusively do video streaming nowadays. In fact, my 4-year anniversary with Zype was last Saturday. So, moving on to today's topic, we're talking about CDN performance and cost economics. Quick rundown of the agenda. About Zype, CDN evaluation process, testing methodology, approach, evaluating KPIs and results, and what we learned along the way. And interestingly enough, I did not expect to learn what I did at the end. The results were not what I had intended, so it was quite a surprise. So that's a little tidbit at the end. Quick little blurb about Zype. We are an OVP. We are a complete cloud and content management distribution infrastructure. We are a SaaS platform. We are a multi-cloud provider. We are multi-CDN distributor, so we use several. We do OTT apps, we do linear live, we do linear playout, which is a brand new product as part of the reason for this endeavor. We were founded in 2014. A little bit more about our services. You notice streaming over there on the side. CDN agnostic, that's a heavy pull into what we do now. We don't care if you use our CDN or not. Obviously, if you do, we want to make sure it's the most economical as possible. So, again, why we went through this endeavor. So, as a multi-tenanted video infrastructure and software platform, we're always looking for ways to improve and deliver increased efficiency, cost optimizations, more robust solutions for our clients, the typical things you would hear. However, in 2019, Zype underwent an intense strategic analysis to determine optimal CDN setup and partners for digital video distribution. We're growing, and delivery costs are steadily increasing. The larger and larger clients that are continuing to inbound, we should probably consider evaluating our options regarding our delivery strategy. So I myself asked the question, well, and this is in all seriousness, are all just CDN providers more or less the same nowadays? Should we just go and fight for a better rate? The truth is, I didn't have a real answer to this question. And that led us along this path. So, you know what we should do is define methods for testing criteria applicable to your use case and compare potential prospects. And we did that. So what do I call the big three for a CDN rubric? This is as high level as you could possibly get. This is to do with evaluating 3 providers. This is more or less the mandate. Pick 3 name brand CDN providers. Core criteria was basically evaluate performance, cost, and feature sets. And in the actual integration, well, what would it take to tie these guys all into the Zype platform? And that's kind of where we started. And we're going to need some performance metrics. So the ones that we primarily focused on was time to first frame, caching policies, cache hit ratios, reducing origin hits by advertised features. Some CDNs have some features, some don't. What is the great equalizer? No one really knows. We have to build a system to test all of these things. Obviously, origin egress is a concern. We are a SaaS provider that operates exclusively in the cloud. As such, all of our origins are in the cloud. And as anybody try to transfer one bucket from one cloud provider to another, or one CDN to another, you know you're going to get egress costs, and Amazon's going to beat you over the head, or Google, or anyone else. So that was highly important to our cost structure for this evaluation. Playout performance is obviously where a lot of the time to first frame values come from, as well as all the other metrics that you would expect to see when testing a CDN provider. And that's where we started. With that in mind, we also want to discuss the cost implications. Those are performance, these are costs, both positive and negative, of said performances, which equates to a bit of a balancing act. Based on what cache hit ratios and performance considerations are over time, how can we effectively improve upon them and keep them in line with cost? And where cost starts to play. Now, how long can we keep origin requests cached on the CDN side before the assets themselves expire? I think we don't put enough emphasis on that, particularly with the understanding the cost structures and the architectures around hyper caching. mid-tier caching, origin shield caching, and the architectures that go with it, and then with regionalized caches, and then global regionalized caches. And I said a bunch of stuff there, so maybe I should stop for a sec. Everyone in the industry kind of uses a different term for it, right? We hear origin shield a lot. We mostly know what it is. It's just a front-side cache. And then we also hear mid-tier a lot, which is a more or less architecture for caching the regional caches. So if you have a lot of requests coming out of New York City, you want to put a cache in front of your standard caches. And the interesting thing is about different CDN providers' architecture of these mid-tier caches, these mid-level caches, are sometimes they charge you for them and don't really tell you about it, which is a hidden cost that I know I've ran into a few times, not just at this company, but others, that obviously need to be taken into effect because they affect the overall not only cost, but you know what your bottom line gigabit rate would be for delivery. You need to take these costs into account, otherwise you're not obviously going to get your return, or your margin's going to be sincerely diminished. Okay. We also need to understand egress and cost for your origin requests. Now, I had mentioned this earlier, but how much transfer costs would be incurred over time, and this is for every day, every month, every year, and understand those caching policies and how they affect the origin. Now, this was particularly critical for me, because I asked myself the question, if I just took up all my content in my origin bucket, whether it be S3 or GCS, and I just threw it into a cloud provider, like the cloud CDN, how long can I keep it there? And if I do keep it there, are you going to charge me for it? Now, I actually thought the answer was yeah, of course they're going to charge you for it, it's their storage. Now, that's not always been the case, and that's a beautiful thing, because if I keep any of my origin requests on there for an expiration period of 1 year plus, then I never have to have any more origin or egress costs anymore. And they said, well, let's try to find that. That would be great for us. So we did. We went out to do that. And another rehash of what we're talking about features I only really care about. I only care about origin shields and hyper caching for this exercise. I only cared about mid-tier caching architecture and implications. Security features, obviously, you have your OAuth models and tokenization of assets, which assets we want to tokenize, which ones we don't. Origin egress and routing. I'll get to BGP implications for network topologies at the end. It is important for all of this, although it's not easily discoverable. And what I mean by that is, what is the exact hop count and network topology from your bucket to your CDN ingest? Now, if you are inside the same cloud provider, obviously it's free. Those costs don't apply. But if you want to use an external, you want to be able to get it geographically and latency close and hop count reduced as much as possible. So that all these things need to be factored in. And, cost, obviously, number 5. In testing methodology and criteria, we want to be very simple. We try to want to equalize this as much as possible. Real world testing endpoints and players. I want to be able to test from all around the world, North America being the primary, but I want to be able to test all around the world, multiple regions. I want to be able to simulate real traffic loads, and I want to be able to test that performance, and I want to be able to do that across all the providers that I am prospecting to either add or replace existing. And I want to be able to test them frankly, in a systematic way. I'm not going to run around and run a script all day long. I want to be able to test them in a systematic way, an unbiased way, to test, record, and analyze, and then repeat and repeat. So, to do this, in steps goad. What's a goad? Well, I didn't know, but actually in the English language, goad means to poke or prod an animal. And I said, well, if I'm going to build a massively distributed testing architecture, the first one I would turn it on is my CDN. Anyway, but notice a Go.js application. It executes a Lambda. If you used Lambda, raise your hand. You know what I'm talking about? No, this is less than I had thought. Lambda is, think about it as a serverless architecture. It is 25 to 100 megabytes of code. You can use it in Ruby, Python. Node is what I selected. I'm pretty familiar in all 3 languages, but I think Node is applicable to us since we're dealing with web players' web requests. It runs once within 300 seconds and kills itself. No servers, no nothing. It's completely serverless. It was perfect for this. My test didn't run more than a couple seconds, if that. So, depending on the test I was running, so it was perfect. Why did I use it? Because it comes in a nice little package, and within, and I'm not joking, within maybe 20 minutes, I had it running in Southeast Asia, in London, in US East, in US West, in US 2 in Ohio, all around the world. It just deployed with simple command lines and allowed me to make player requests, to watch players, to test what I was actually about to test, simulate clients, and it can do it at scale. And for the purpose of this architecture, as you can see, Goat is just a function, a Lambda function. The same thing can be done on Google Cloud, just a cloud function, no big deal. But US East 1, 2, West 1, and Northeast, which is AP Northeast 1 is Southeast Asia, which I was particularly interested in. How it operates by executing this code is basically you can tell it to do whatever we want. In my case, I said, make a player request design from X location, start playback, record these pieces of information, write it to JSON, fire the JSON into an S3 bucket back in Virginia. Simple. That's all I wanted it to do. The beauty of it, though, is I can turn up the dial and I can make 100,000 requests in under 5 minutes, which really starts to simulate production load. Now, if I did that in all the regions, now I'll have production traffic. One guy creating an entire production traffic load, 20 minutes. That's why I chose Go. My testing framework leveraged as the follow. Platform staging environments configured for each of these CDN providers that I wanted to test. I built independent, and with containerization, this is simple. I spin up a Zype, spin up a Zype, spin up a Zype, spin up a Zype. Couple minutes, and then I'll have independent Zypes all put there, and I created unique configurations. Obviously, it's not as simple as that. I need API keys and tokens and SDK classes. So we created Zype running on X provider, X provider, X provider, X provider. So we had a baseline to work off of. Go to microservice, utilizing Lambda functions, obviously generating the player request traffic I needed. SQS for gathering the results. Storage S3 of those results, and then we actually used AWS Lambda, so Athena, for tabulating those results because Athena works great for flat file systems. And in general, it requires very low overhead. They allow you to create or extract the DDLs without much work or effort. And again, this was a one-man operation, and that's how I attacked it. I just used Athena, I had it, it was there. Sometimes you just need to work smart. Regions we tested them, we've already went over, but now I want to talk more about the assets involved. So I did 10 VOD assets per provider, and then 2 particular live streams. What's interesting about the assets is the way I chose them. Obviously, I have some that are static. I needed my baselines across them all, but I also needed particular assets that are encoded a little bit differently. Now, for the purposes of this test, and I know it mentions it in the book, I was going to talk about codecs impact on delivery costs. I'm not going to do that because I feel that there are better people who can talk about codec design in general. I'm using H.264 today. I probably will be changing it in the future. But in general, let's just say everything's good with H.264 and leave it at that. I'm sure there's a lot more people in the world that can talk about the codec impact to file size and delivery costs. And the content was a mix of very fast-moving content, car races, car shows, etc., and static podcast, green screen, etc. So I had both dynamic and static content as my testing bed, some of vary durations, some that are not. Scale of the test. How do I want to actually test my concurrency and sustain testing durations? I scaled from 1 request a minute to 10,000 every 5 minutes, and I did do a 100,000 requests in 5-minute test, although it started pushing pretty hard when you have that many requests on top of your already production load. And I didn't want to freak anyone out on prod, so I started to dial that back a bit. But in general, it would scale it regardless, but this is a test, and I didn't need to prove if Core could take it. Number of tests executed, well, we did it over a course of a month. All the CDN providers we did, typically tests would span over several days. We executed tests over the course of, I just reset that. Sorry, my notes are duplicated. Okay, and the analysis architecture, this is, again, really straightforward. Go and dumping everything to an S3 bucket. I used Glue to extract the DDLs from the JSON files. It's not too hard. We're pulling that many values. And then I had Athena read it in real time. Athena is great because it allows me to sumo logic them, right? That's why they built it. It allows you to query them just like as you would SQL, but except flat files without having to put it into a database. It's a flat file database. Quick, dirty analysis. Yeah. And I want to run through a couple questions we had around our test and results before we actually get into them. questions that we would ask myself, or I would ask myself. How long can I keep the origin requests in the cache? Now, the caching policies themselves on every CDN tend to vary. Obviously, some are 3 months, some are 6 months, but it's disadvantageous for a CDN provider to hold your content for X amount of time because they physically have to hold that on storage. If you do find a provider that lets you, which we did, allow us to put an expiration policy of up to 1 year, and perhaps they'll even push that, then that's great. That means I'll never have to see an origin request for the same piece of content ever again. And that's huge, because in the cloud, origin and egress costs matter. What are my time to first values per provider? Obviously, extremely important, particularly geographically. I want to know what it looks like downtown Chicago. I want to know how fast my player is starting up with this CDN versus this CDN. Well, everything else remains the same. In the middle of Oklahoma, in the middle of the Southeast Asia, all over the world. This is things that we already know, but obviously I want to keep that testing methodology and those numbers. I want those numbers. If all player conditions are equal, I also want to know how long did it take to make a player request. This is more of a vanity metric for me. I want to see how the core platform is responding all over the world now that I've built this fun thing. I want to know how long it takes to download a manifest. Masters for VOD, we also cache within our CDN providers. That's really important to me. How long did it take to queue in a player is also a vanity metric because that also tests my player's ability to spin up that manifest. How fast is that player moving? Maybe we should just fly in a new player. Who knows? That could be for a further project. How long does a chunk take to download? First chunk to download is important to me because segment size, for whether it's Dash or HLS, are constantly a concern of which one's better. And as we move into CMAF and continue to go towards Dash, segment size is becoming something that's critical. How far do I want to scale up to still have that bufferability? And it's another balancing act. Or how much latency do I really want to have per packet, per chunk? Obviously, playback and per region scale. So how much content can I actually watch in any particular region and the results of said results. And there they are. So there are CDN results 1, 2, 3, and 4. CDN 1 is our current CDN provider. We pushed that's just for the purposes of the test. This is all fake. No, their data is real, but the data I was playing was my test videos. But I pushed about half a petabyte through and an origin egress of 367 terabytes, which is horrendous, which gives me an average efficiency of 63%, which means I am paying for every gigabyte above 63% being pushed across my origin. CDN2's efficiency was astronomically good. CDN3 pushed almost 5.2 terabytes of data. Their efficiency was also pretty good, but I think we're starting to lean CDN2 at that particular time. CDN4, I gave up. And that's the honest God truth. How many errors? Too many. Just move on. There's not enough hours in the day. With all of that said, what surprised me about it is the first conclusion drawn was, I go back to my original thesis question, was, are all CDNs the same? No. The highly commoditized aspect of CDNs is perhaps a whitewash. They are getting similar. It is commoditized distribution of content, but the architecture, the individual delivery methods, and how they cache truly do matter. The numbers speak for themselves. It's a month of running. And I was surprised by that because in the end, those percentages are real dollars. 63 to 70, or 63 to 98.9% could be 70 grand. It's money. It's money that we don't want to throw away. Average latency wasn't so bad across them all, to be honest. And I drew a line on this chart. This is over the month of testing. Excuse me. But there is an obvious inflection point. As the origin cache starts to, initially when you do have your initial origin hits. So a player makes a request for a video the CDN's never seen before. It goes to the origin, grabs the chunk, puts it into the hypercache. Now it's there forever. Great. But during that process, you're obviously going to have longer times. Why? Because I have to go from player to CDN to origin and back. But once the cache kicks in, you have more or less nominal, or what I would hope to expect. All that last hop goes away, and also the egress cost goes away because I'm able to keep those caches there longer. With cloud providers or distributors that are running much more traffic than I am, the cost of savings will start to speak for themselves. Okay, understanding our breakdown of costs by API this is just more questions I would ask myself going through the whole process is, how is the content delivered? How much did that delivery cost? How many origins requests were made, as we saw in the previous chart? How much did I pay for that origin transfer and those upfront costs? And we physically did that. We went and turned on object logging, because it was S3, it was origin at the time. It's not anymore, based on these results. We actually went through and tagged every object, millions and millions of objects, and summed them all up and said, hey guys, this is how much we're getting, and you're obviously not keeping up with us, so we're gonna move on. How much did I pay for the origin request? What are my fixed CDN platform fees? Obviously that matters, right? In the overall total cost of ownership, we obviously have platform and feature fees. Origin expresses as well, egress, and codecs and advanced features. Like I said, I'm not going to get into the codecs. You compress it more, it's less data to send, we know. But it's harder to implement than that. I have to support 28 downstream endpoints. Samsung Plus, Roku, Amazon Fire, I have to support all these players. So I'm going to get to a higher end codec in the future. And that's how we came to our conclusion. This is a real customer use case. This customer pushes a decent amount of traffic. And this is, by the way, just so I'm not making it up, this is a snapshot I took about an hour ago. So this was just an individual client. They did 16.8 million requests in the last 5-6 days, 7 days. And as you can tell, it's doing 92.8%. Why? Because all the majority of that traffic is already on that CDN. The cache efficiency is really good, and the only time it ever goes back to origin in the first place, I don't know what happened to the screen there. There it goes. The only reason why it goes back to origin in the first place is to get new content, which they constantly add. They add entire blocks of seasons. So that compared to our 54 to 63%, and that's for VOD and live, is a fantastic improvement, 40% improvement on what we had before. I only expect it to go higher. Because, now for live, obviously that content's constantly changing, it's hard to cache. But for VOD, I do expect that to go higher as they start slowing down with new content, or it becomes cached on its own. And we applied this to, well, not yet, but we're in the process of applying this to every single client we have as our default CDN, as well as our secondary and our tertiary CDNs. Okay, quick conclusion, wrap up. Caching policies, the longevity of the asset sitting in your CDN is extremely important. As we've already discussed, decreased overall origin requests. This decreases overall CDN transfer costs if applicable. As a provider, origin egress, particularly when operating origins within the cloud, can make or break your delivery margins, and that is absolutely true because that's happened. Routing and first hop considerations, and I told you I'd get to network topology at the end. So origin egress transfer costs are directly related to outbound traffic egress. And to optimize routing, understand the network topology between your cloud origin and your CDN of choice, if not all of them, because there could be hidden cost savings there. So what does that all mean? Now I don't have a chart for this, but as you can imagine, if my origin is sitting in Virginia, and my ingestion point for my CDN of choice is in Iowa, I just added 10 hops of traffic, I've added half the country, 32, 35 milliseconds, it takes 90 milliseconds to get to London. I just added a third of that. It's all adding up to A, I have to pay for the egress. B, I just added latency. C, I just added a lot of complexity. Why? Because there was an article not that long ago in Wired, or was it Wired? I think it was Wired, but they were talking about, are all ISPs the same? Which I find fascinating because I'm writing this. And the truth is, no, they're not all the same. And that makes sense. Everybody has different budgets, everybody has different networks. But from a BGP routing perspective, it doesn't care. It doesn't know what these networks are running on. If one network goes down, it's just going to use another advertised route. And that ISP, it may be very underpowered, very underfunded, and they might be using not superior equipment. So there's a lot of considerations to take in when we're talking about moving origins and making them closer to your ingestion point. And in the end, I was able to get a highly detailed map of where my origin will be and where my preferred CDN of choice is. And now I have 2 hops. That's how long my origin takes to get to my CDN backend. 2 hops. And I got a reduced rate on that too. So it's all about figuring out all those points. It's no longer 15, it's 2. And that was a big win for us. And that's it, guys. That was it. I know Amazon was supposed to speak at the end of this, but they bailed. So I have sometimes some questions if anybody has any. If not, I'll let you guys go early. Yeah.
So the synthetic tests with the particular cloud providers, that sort of favors said cloud providers, CDN?
You know, the only, well, I didn't, the tests that were up there was from legitimate traffic from CloudFront. Yes, because that was our existing CDN. So if I go back to that slide, hold on. Where is it? These results were not done with Go. These are actual facts. They were actually done from that production month at that time. So I didn't use Go to test that one.
So you're comparing synthetic to real world?
Yes. I had no other choice at the time. And we were okay with that. We're okay with that. It was the efficiency ratings that we were more interested in. And the real world use case is real world. And it was what did I say? Estimated 98.9. We kind of thought that was plus or minus 2. We're getting 92.8. It's close-ish. Yes?
A big part of cache hit efficiency is, of course, going to be how big your cache footprint is and
Yeah.
how often it's getting evicted and such.
Right.
What did you do to manage the spread across version and, represent a longer tail, or what's the breadth of content that you're asking for?
Well, the breadth of content for the origin was, we preloaded it. So we took the entire origin and moved it. So it wasn't just selected. That was the whole beauty of finding this provider. So once we heard that they were willing to do so, yes?
Were there other considerations other than just like cache hit ratio, specifically speaking, like response times, time to first bytes and things like that?
Yes, there was.
And also like feature sets.
Feature sets did vary, but understand that lowest common denominator was really the only true equalizer. I mean, I could speak to a CDN provider all day long. Well, my feature does this, and that makes it better. I get that, and you know what? Sometimes they're right. If we tweak this little thing, sometimes that isn't the case. But I needed it to go flat as possible. We're a smaller company, but this was my initiative, and I kind of just went, let's keep to the basics, because the basics ultimately are what matter. We tune from there. We could tune from there. Anyone else? Yes.
How are you going to make your plays select the best CDN in whatever country around the world you might choose to deliver content?
Make your plays?
Select the right CDN. It sounds like you're getting all of those data, right?
Yeah, well, that's due to DPT. So Zype has a patent that we, inside the Zype platform is a US and hopefully EU one-time patent called dynamic player technology. It's a code structure that basically does a lot of business logic on the fly in MEM in real time. It evaluates, I couldn't even remember the whole list, but a lot of it has to do with DPT. So as long as I cloned Zype, I knew I was going to get the best for that particular environment. So you could statically set an individual asset to only use the CDN provider, or I could, a number of different business rules, geography, geo-restrictions, hop count to the nearest edge, etc.
Was storage part of this consideration as well? Storage or
Yes, it was. I did not put it in the presentation. The origin we ended up using is cheaper.
Sorry, what?
The origin we ended up using in the end after the optimization is infinitely cheaper. And again, the hop count to the ingestion point of our preferred CDN is 2 hops now. So that was a big consideration. Yes, I know. That's a tall ask. Pick up your origin and move it. But effectively we said, let's do it.
That's a lot of data.
It is a lot of data to move. It took a few months.
We're smaller than a petabyte, that's just.
Yeah, it took a few months. But it's done. I know. It was an interesting meeting, but we're talking about long-term longevity, cost, scalability. We want to be able to be in the situation now where we can just ramp. And I don't think we'd be moving it at any time in the future. I think we're pretty happy with where we are.
You consolidated as a single CDN?
Yeah, but we're replicating it for, now, see, the thing is, we are removing all of that for the cost benefits of this one particular origin. The future of the ramp will be multi-replicated regions with localized origins. There is no sense for me to have people in Southeast Asia picking up content, pushing it into Virginia to only be advertised in Virginia as an origin. I totally get where you're going with it. This is this step. This is this project. We're getting there. Okay. Thanks, guys.